Okay, let's dive in. In today's world, everything feels increasingly digitized, right? And powered by really sophisticated AI.
Definitely.
And with that comes this huge growing demand for something incredibly valuable, digital privacy.
Yeah, absolutely critical.
We're talking about your most sensitive data, think personal health records, maybe confidential financial trading strategies, or even the unique data that trains your own personal AI agent.
Right, the stuff you really don't want exposed.
Exactly. But here's the challenge. How do you actually use this data for, powerful computations or analysis without ever exposing it to anyone, not even the service doing the computation?
That really is the core problem, isn't it? Most traditional systems, and honestly, even many modern blockchains and current AI setups, they just, well, they can't handle truly high-value private data effectively.
So using it means revealing it.
Pretty much. Using the data inherently means revealing it, which is, like you said, a non-starter for so many critical applications. And yet, there's this huge potential, this need for a new wave of Web3 apps that genuinely require working with sensitive data privately.
And that need, that gap, is what brings us to Nillion today. Based on the source material you shared, looks like a project overview and a pretty detailed report on their network token ecosystem.
That's right, quite comprehensive.
Nillion is setting out to solve exactly this challenge. So our mission in this deep dive is to really pull out the essential concepts, the tech behind it, their progress. Basically understand how Nillion proposes to handle secure data storage and computation for blockchains and AI in what sounds like a fundamentally new way.
Yeah, and what's fascinating right off the bat is how Nillion defines itself. It's a permissionless network built specifically to provide secure data storage and computation for both blockchains and AI.
Okay, permissionless storage and compute.
And their central concept, the real linchpin, is enabling storage and computation on data while it remains completely encrypted.
Ah, and they call that blind computation, right? I saw that term. That feels like the core promise here.
Precisely, that's the term they use, and the value proposition is really clear. Unlock entirely new applications, new use cases for sensitive data. Like imagine giving a personal AI agent access to your private files to serve you better.
Without it ever seeing the raw files.
Exactly. Allowing that data to be used and computed upon without ever being exposed or revealed to any party involved in the process. That's the goal.
Okay, so computation on encrypted data. That sounds, well, incredibly complex. How do they actually achieve this blindness? What's the tech?
According to the report, it utilizes what they call an orchestration, a specific arrangement of privacy-enhancing technologies, or PETs.
An orchestration. Interesting. So not just relying on one single magic bullet technology.
Right. It's presented as a combination.
And the source list specific ones.
Yes, it explicitly mentions multi-party computation, MPC homomorphic encryption, and zero-knowledge proofs.
Okay, yeah, we've definitely heard of those individually in different contexts. MPC for secure signing, ZKPs for scaling, and privacy proofs. What's the significance of combining or orchestrating these specific PETs together, especially for computation on encrypted data? That seems like the unique claim here.
Well, if we try to connect the dots based on the material, the real insight seems to be Nillion's claim that their specific orchestration of these technologies lets them distribute a computation across a network of nodes,
Okay.
such that no single node, or even, the network acting together, ever needs to decrypt the original data to actually perform the calculation.
Right, so the privacy is maintained throughout.
Exactly. MPC lets different parties compute together without seeing each other's raw data. Homomorphic encryption lets you compute directly on encrypted data, which is amazing tech in itself. And zero-knowledge proofs let you prove a computation was done correctly without revealing anything about the data itself. So combining them in their specific way aims to create this robust, distributed system for processing information while it stays totally private. That's the blind part.
Okay, so that makes sense. Conceptually distributed privacy through this orchestrated tech stack. Let's look at how this is actually built. The source describes Nillion's network architecture, says it has two major components working together.
Correct. Think of it maybe like two layers. There's the Petnet layer that's specifically designed for that blind computation we were just talking about.
So that's where the secure processing happens.
Yes, exactly. This is where the data processing happens without revealing the content. It's described as being made up of separate clusters of nodes, and potentially these clusters could offer different configurations or specific privacy technologies.
Interesting. Flexible clusters. And the other layer?
That's the coordination layer.
Mm.
This acts more like the network's transactional and organizational backbone.
Okay, the management layer.
Yeah, you could put it that way. It handles things like payments for services, allocating the computation resources on the Petnet, routing requests between network participants, all the operational stuff.
Gotcha. Are there any technical details provided on how these layers operate or communicate, like the consensus mechanism?
Yeah, the coordination layer uses a consensus mechanism called Comet BFT. It's
Mm.
noted as a fork of Tendermint, which many people in the space will recognize.
Right, common in the Cosmos ecosystem and beyond.
Exactly. And it operates via a delegated proof-of-stake DPoS model. Again, pretty standard stuff. Validators secure the network by bonding or staking their tokens. And their voting power comes from both their own stake tokens and tokens delegated to them by other users.
Okay, DPoS for the coordination layer. What about the Petnet?
For the Petnet, the stated long-term goal is apparently to allow anyone to spin up their own computation cluster, so aiming for decentralization there too.
Right, and the report notes a key difference in this architecture compared to, say, traditional blockchains. Something about state.
Yes, and this seems pretty critical for their scalability claims. It explicitly states that the network operates without relying on a global shared state.
Ah, okay. Unlike, say, Ethereum, where everyone needs to agree on the entire world state.
Precisely. That lack of a global shared state is presented as a key architectural choice. It's what they say enables both vertical and horizontal scalability, meaning they can distribute workloads more efficiently across these clusters, potentially allowing the network to handle significantly more computation volume than a traditional chain might.
Efficiency and scalability, definitely non-negotiable if you're talking about potentially large data sets and complex AI computations. Okay, let's shift gears slightly. The token. The native utility token is called NIL.
That's correct. And the source material details 4 key functions for the NIL token within the Nillion network.
All right, what are those primary uses? Lay them out for us.
Okay, first, it's essentially the fuel for the coordination network. It's used for transactions, for accessing the network's resources, and settling the costs associated with using services across Nillion.
So standard utility. You need it to pay for things on the network.
Yes, it facilitates all the economic activity.
Yeah.
Second, and this is key, users and developers rely on NIL to actually access those advanced privacy-preserving computation services. The blind computation happening on the Petnet layer.
So you pay an NIL to use the core privacy tech.
Exactly. It's how you pay for using the core technology for your applications. Direct utility for the main service.
Makes sense. What's number 3?
Right. Third, there's staking. Like many DPoS networks we see, token holders can stake their NIL. This helps contribute to the security of the network, and they earn rewards for doing so. Validators, as we mentioned, need to bond tokens to participate in securing both the coordination layer and potentially aspects of the Petnet too.
Got it. Securing the network through staking incentives. Standard, but important. And the fourth function.
The fourth is governance. Holders of the NIL token are intended to participate in decentralized governance.
Okay, DAOs and voting.
Pretty much. This means they can propose and vote on important decisions about the network's future. Things like protocol upgrades, maybe adjusting network parameters like fees, how resources are allocated, or even community grant initiatives.
So it's got both operational utility, paying for stuff, securing the network, and governance power baked right in. Seems comprehensive.
Yeah, it covers the main bases you'd expect for a network utility token.
Okay, thinking about products and ecosystem growth. The mission recap was enabling that next wave of Web3 applications needing private data. What does the source tell us about how far along they actually are, and who is building on Nillion as of that report date, March 21st, 2025?
Well, as of that date, the report highlights pretty significant ecosystem traction. It states there are over 50 projects already building on Nillion.
50 plus. Okay, that's notable traction.
Yeah, and it also details some specific existing products Nillion itself offers to developers to, make it easier to build these private apps.
Like Nil AI. Saw that mentioned. What exactly is that?
So Nillion, as described, provides specific tooling for building private AI applications. This includes things like the AI VM and NLTs, which seem geared towards helping with larger model inference privately.
Okay, for running bigger AI models securely.
Right, and there's also a component called NADA AI, which is described for smaller, more programmable inference and also federated learning scenarios. And importantly, a private RAG SDK.
RAG, Retrieval Augmented Generation. That's huge for LLMs accessing external knowledge. So a private RAG.
Exactly. It allows large language models to access private data stores, say, your personal documents, to generate responses, while specifically aiming to minimize data leaks from that private data during the retrieval and generation process.
Wow. Okay. Private RAG is definitely a huge need if we want truly personalized AI assistants. What about just secure data storage itself?
That's where NilDB comes in. It's presented as an encrypted, distributed NoSQL database, specifically designed for storing sensitive data privately.
How does it achieve that?
It seems to work by distributing trust. The data is split up and stored across a cluster of nodes, with each node holding only a secret share of the data.
Ah, like secret sharing schemes.
Seems like it. No single node has enough information to reconstruct or see the original data. Distributing those secret shares is a pretty smart way to prevent single points of failure for privacy.
Makes sense. And for developers who actually want to build these kinds of privacy-preserving applications, is there a dev platform?
Yes, there's NilVM. It's described as a platform for builders to program these privacy-preserving applications. Apparently it uses a Python-based domain-specific language, or DSL, which could make it more accessible for many devs.
Python-based, that's interesting.
Yeah, and it also includes something called a DESIG SDK. This uses MPC multi-party computation signing to help abstract away the complexities of managing private keys across different blockchain chains. The idea is to make it easier for developers to build cross-chain private applications.
Okay, so they're providing tools for private AI, NilAI, secure distributed storage, NilDB, and a developer platform with easier key management, NilVM. That covers the product side pretty well. Let's look at the project's journey milestones, funding, business development.
Right, the source notes they've raised a significant amount of funding totaling $52.7 million across 3 funding rounds mentioned.
$52.7 million,
Yep.
okay. And it lists key completed milestones with dates up to early 2025. Looks like a timeline here.
Yes, it gives a pretty clear timeline.
Sure.
Let's see, $25 million raised in pre-seed and seed rounds between Q2 and Q4 of 2022. Then the Nillion coordination layer testnet launched in Q2 2024.
Okay, testnet mid-2024.
Then, testnet chain integrations with Near, Arbitrum, and Say went live in Q3 2024.
So connecting to other major chains early on.
Seems so. Also in Q3 2024, another $25 million was raised in a Series A round led by Hack VC. Then Q4 2024 saw a research paper co-authored with Meta specifically about private LLM inference.
Meta, that's a big name to co-author with on AI privacy.
Definitely suggests serious exploration of the tech. And finally, the launch of the Nillion mainnet and their token generation event, TGE, is listed as happening in Q1 2025.
Wow, okay, so that's a rapid progression from testnet in mid-2024 to a planned mainnet in TGE in early 2025, according to this source. What about the commercial and business development side? The report details quite a few partnerships and, importantly, how those partners are actually planning to use Nillion.
Yeah, this is where you really see the potential applications come alive. Looking across the list, there's a strong signal that this need for private computation isn't niche. It spans many different sectors.
Like what? Give us some examples.
Okay, so on the infrastructure side, for instance, Saudi Telecom is noted as establishing a Nillion Petnet cluster. So they're actually building infrastructure on Nillion and planning to offer a product using Nillion's blind computation.
Whoa, Saudi Telecom. That's a major traditional infrastructure player engaging directly with this tech. That's significant. And the Meta research paper points to AI interests, too.
Absolutely. It shows serious exploration of Nillion's tech for a really critical privacy-sensitive AI task. Then there's ZAP. They work on decentralized data infrastructure using ZK-TLS technology. They're listed as using Nillion for encrypted storage, computation, and AI model inference.
Using the whole stack, basically.
Seems like it. And they're powering applications like AI Lingo, which the source mentions has over 50,000 users already verified. That sounds like actual usage showcasing the tech in the wild.
Okay, so real-world adoption starting to happen there. What about integrating with existing blockchains? You mentioned Near, Arbitrum, Say earlier on the testnet integrations.
Right, and the partnership section elaborates. Near is integrating Nillion's blind computing into its Near.ai initiative and connecting its chain so that apps on Near can send blind compute requests to Nillion with settlement happening back on Near.
Okay, extending Near's AI capabilities.
Aptos is doing something similar, connecting its chain to enable dApps there to send blind compute requests with settlement on Aptos, expanding their data privacy capabilities for their ecosystem.
So enabling private computation for dApps on these major Layer 1 chains makes sense.
Arbitrum, the Layer 2, is integrating Nillion's blind computing and connecting its chain too. This is specifically aimed at enabling use cases like private DeFi applications.
Private DeFi, like preventing front running.
Exactly.
Yeah.
Potentially using blind trade execution to help prevent front-running and harmful MEV minor extractable value. That's a huge pain point in DeFi.
Definitely. And say?
Say is integrating Nillion to enable use cases like private and verifiable gaming implementations on their chain, addressing issues like potential game manipulation or cheating, and ensuring asset privacy for things like in-game credentials or items.
Preventing MEV in DeFi, ensuring fair, verifiable gaming. Yeah, those definitely address significant pain points for users and developers. Big potential impact there. Now, looking at the specific application use cases across different sectors, the source material details a whole bunch of partnerships in AI agents, data health genomics, and identity security. Let's break those down a bit.
Okay, starting with AI agents, it seems like a major focus. Several projects are listed as leveraging Nillion specifically for privacy in AI agents. Virtuals, for example, is integrating blind computation for storing private documents securely to power more personalized agents.
Right, using your own docs privately.
Then there's I16s. Through their ELIZA project, they're integrating for secure storage and widespread blind computation usage. And interestingly, enabling secure communication between different AI agents.
Secure agent-to-agent communication, built on privacy. That feels pretty essential for a future where we have lots of interconnected AI assistants working for us.
Seems like it. Base, using their CDP framework, is also enabling the storage of sensitive data on Nillion for building secure personal agents. They're also aiming for widespread blind computation use and secure agent communication.
Okay, another one focused on secure agent interaction.
Pandora's Lucy IA assistant is using Nillion for secure storage and computation. Specifically mentioned as providing private message retrieval and AI insights while protecting user privacy. And CapEx, described as an Ethereum L2 focused on AI agent deployment and monetization, is integrating Nillion specifically for private AI inference and private semantic search, that RG capability again.
And why is that important for CapEx?
It allows developers on their platform to potentially monetize their AI models or access to data without exposing sensitive model parameters or the user's private input data during the process. A key enabler for a private AI economy.
Okay, that's a really comprehensive set of AI agent partnerships, all fundamentally reliant on this privacy layer Nillion provides. What about data, health, and genomics? That sounds like another area where privacy is paramount.
Absolutely. Monic DNA is partnering to secure sensitive DNA data. The goal is generating private insights into health, ancestry, personalized medicine, all without exposing the raw genetic data itself.
Huge implications there.
Yeah. And they also aim to enable secure research collaboration and potentially new monetization models around this highly sensitive data while maintaining user control and privacy. Then there's Stadium Science. They're using Nillion to store and process private user health data.
For what purpose?
With the goal of creating prediction markets based on health data and potentially enabling entirely new markets derived from consented user data, again, processed privately.
Prediction markets on health outcomes. Wow, that's a really unique application only possible with secure private data processing.
Definitely pushes the boundaries. Fulcra, which processes personal data from smart devices, is using Nillion for storage and encrypted collaborative analysis. The idea is to generate population-level insights while ensuring individual data privacy is never compromised.
So learning from the aggregate without seeing the individual data.
Exactly. They aim to unlock knowledge that can then power AI-driven personalized advice. Health Blocks aggregates user data while preserving ownership and uses Nillion for private computations. This enables things like activity pools or allowing third-party insights without leaking the underlying data. They also mention using it for gamifying fitness privately.
Interesting. What else?
SwordChain, which is a mobility-dependent platform decentralized physical infrastructure for vehicles, uses Nillion for private computation and storage of vehicle data.
Why would a car need private computation?
Well, for enabling secure sharing of data for smarter driving applications, or allowing third parties like insurance companies to access anonymized insights for better risk assessment without revealing specific driving habits or locations.
Ah, anonymized insights for insurance. Got it.
And finally, in this category, Reclaim Protocol. There is DKTLS platform for proving off-chain identity or reputation. They're listed as using Nillion as a platform for storing and processing sensitive verified data privately, offering decentralized storage, data composability, and secure privacy-preserving processing of data that's already been verified as authentic.
Okay, that's a really broad spectrum. Smart devices, health, genetics, vehicles, verified credentials. It really touches on a lot of sensitive data areas. Finally, what about identity and security use cases?
Two listed here. Blurify, which focuses on wallet-based verification, is integrating Nillion to securely store user keys and sensitive identity data. The goal is enhancing security and privacy for their users' digital identity.
Secure key storage using Nillion's tech.
Seems like it. And Mighty Network, which provides secure AI-driven cross-chain liquidity, is using Nillion for blind computation integrated with on-device AI. This is aimed at ensuring privacy for secure, self-custodial multi-chain operations.
Okay, wow. Just looking at this whole list of announced partners and use cases pulled from the source, the need for computation on private data really does seem to span pretty much every digital domain imaginable. All right, let's quickly touch on the NIL token economics overview provided in the report before we wrap up.
Sure. As of that date, March 21st, 2025, the Genesis total token supply is stated as 1 billion NIL.
Yeah.
1 billion total.
1 billion total at Genesis, and the initial circulating supply upon listing.
That's noted as 195,150,000 NIL, which works out to 19.52% of the total Genesis supply.
Okay, about 19.5% circulating initially. Any mention of inflation or maximum supply?
Yes, the source mentions a maximum token supply mechanism. It's described as a 1% yearly inflation, but that's intended to be offset by deflationary pressure coming from network usage fees being burned.
Ah, okay. So usage-based deflation potentially balancing out or overcoming the fixed inflation. That's a common model. It also lists the standard token distribution categories, right?
Yes. It details the typical allocations: ecosystem and R&D, treasury, private sale investors, public sale, community, launch pool, foundation reserve, and advisors and core contributors. Standard buckets.
Anything notable within those allocations?
Well, it does specifically highlight that an additional 25 million NIL taken from the community portion will be allocated for marketing campaigns, specifically mentioning Binance, starting 6 months after the spot listing.
Got it. Yeah. A specific marketing allocation noted. Okay, a clear breakdown provided in the source there. So, to try and wrap up this deep dive, Nillion is really positioning itself to tackle a fundamental challenge in the digital world. How do we enable computation on sensitive data while keeping that data completely private?
That's the core mission, yeah.
They propose to do this using what they call blind computation, powered by this specific orchestration of privacy technologies, MPC, homomorphic encryption, zero-knowledge proofs.
Right, the tech stack.
The network architecture, with its distinct Petnet for compute and coordination layer for management, aims for scalability without that traditional global shared state bottleneck. And the whole thing is powered by the NIL utility token, which handles everything from transactions and accessing computation to staking for security and governance voting.
A comprehensive system design, at least on paper.
And crucially, the report we looked at shows significant momentum as of early 2025, with over 50 projects listed and a really wide range of partners across enterprise, blockchain, AI, health, identity, all looking to build on or integrate with their technology.
It really is presented as a project directly addressing a prerequisite, almost, for the next evolution of digital applications. Those apps that need to move beyond just, say, transaction privacy to actually using and processing sensitive data privately by default.
Which brings us right back to where we started, doesn't it? Given the sheer breadth of partnerships we just ran through, I mean, from major telecommunications firms and genomic analysis companies to AI agent developers and DeFi protocols, what previously impossible or maybe just impractical applications become not just possible, but potentially mainstream if truly secure. Private computation on sensitive data is unlocked.
It really does open up some profound questions about the future possibilities for, well, truly personalized, yet genuinely private digital experiences. What does that actually look like in practice?
Exactly. Like, what does a world look like where your AI agent, for instance, can access your most personal, nuanced data, your health history, your communication style, maybe even your unique financial habits to provide incredibly valuable, hyper-personalized assistance without you having to worry at all about that core data ever being exposed or compromised?
That's the potential future Nillion seems to be pointing towards.
It is, and it's definitely a future we're thinking about. What becomes possible then?